In the Advanced NLP playlist, many of you are requesting for topics like transformers and BERT. It's very easy for me to show you a complex diagram like this and start talking about it. But I'll not do that. Rather, I will break it piece by piece. And this is the first piece of the puzzle known as encoder-decoder. Let's see this first piece of the puzzle called transformer and try to understand how encoder-decoder works. Here are the topics for the video that we are going to learn today. First of all, I want to be very clear with prerequisites to watch this video because this is not a basic level or beginner level concept. Okay, so I will tell you what are the prerequisites to watch this video. Then I'm going to tell you what is the meaning of encoder and decoder by taking a real life example. After that, I'm going to explain you the architecture of encoder decoder in detail. Okay, and in the end we are going to draw a end-to-end flow which will make our concepts very simple and clear how encoder decoder works. Okay, and then I'm going to leave you with some Python assignments. Fine. So first of all guys, to be very clear and very frank on this, if you don't know basics of NLP, then you should first learn basics of NLP and then only come to this video. Okay, so first prerequisite is basics of NLP. And second prerequisite is you must be familiar with architectures such as RNN and LSTM. Now the obvious question is where I will learn these things. Let me quickly show you two of the Unfold Data Science playlist created for this purpose only. Suppose you are a beginner, okay? You are a beginner in data science and you don't know anything about NLP, okay? Go to Unfold Data Science, search for natural language processing playlist. You will find 12 videos here, okay? 12 videos you will find here. In these 12 videos, you can easily learn basics of NLP. Okay. Once you are done with this, then you qualify to go to the advanced NLP concepts, which is covered in a separate playlist called Advanced NLP and Generative AI. Here, there are 6 videos, and these videos cover RNN, LSTM, and LSTM applications. Okay. Please watch these, otherwise the video which I'm going to explain you, the concept which I'm going to explain you will become very heavy for you. Okay. Having said that, let's go ahead and learn the concept of encoder and decoder. Now, if some of you have watched my RNN video, then you will remember that I was talking about various types of RNN. Okay. I was talking about one-to-one. I was talking about one-to-many. Okay. One to many. Then I was talking about many to one, many to one, and then I was talking about many to many. Okay. So encoder decoder that we are going to learn today falls in the category of many to many implementation of RNN architecture. We can use LSTM cell as well. I am just going to explain you pure vanilla flavor of this encoder decoder will be many to many RNN. We can use it. Okay. What is a many to many architecture or what is a many to many flavor of RNN? The meaning of many to many flavor RNN is you give multiple inputs. For example, I will give first word, second word, third word, fourth word. These are my input. And in the output also, I will expect many words. For example, 1, 2, 3, 4, sometimes more than 4 or less than 4. So many words I'm giving as input and many words I'm giving as output. This is the basic of many to many. Okay. Now, what can be the probable use case for this? One simple use case for this can be language translation, like we do in Google. For example, if I say good morning, for example, if I say good morning, and let's say I want to convert it to German, then there can be a different, uh, you know, way of saying good morning in German. So this is a, language translation language translation use case. So suppose you work in an investigation agency. Okay, let's not take any name of any agency, but let's say you work in a ABC agency. Okay, ABC agency, and you are a senior analyst there. Senior analyst. Okay, senior analyst, and there is an intern joining. So let's say intern I will call junior analyst, for example. Okay, junior analyst. Now, in this agency, in this investigation agency, your job is to understand the, you get basically phone call messages, you track the suspicious messages, you get these messages, and your job is to understand what is being spoken in those conversations. Okay. So, what is your job? Your job is to understand the suspicious conversations. Okay. Now, from your experience of years and years working on your assignments, you want to train this junior guy how to decode some information. Okay, what you want to do? You want to train this junior analyst how to decode some information. Fine. So, let's say in your suspicious call, somebody is saying a message called good morning. Okay, good morning. Now, from your understanding, you know that a encoded version of good morning can be abc xyz 1 2 3 4 5 6. So there can be different ways in which these suspicious people say good morning. So what you do, you create a encoded version of good morning and you give it to junior analyst. Okay, what did you do? You took the original message, you took the original message, you encoded it based on your knowledge, your domain knowledge, and you gave it to the junior guy, and you told to junior guy, hey, can you give me the original message from this? And then junior guy should also give you good morning. Okay, good morning. Now, the process which just happened is called encoder-decoder. Okay, so the senior analyst here is basically encoder, which is encoding a message. The junior guy here will be called as a decoder who is decoding the message, and the decoded message, the intermediate message, is called context vector. Context vector. Remember these three concepts, guys. This is encoder decoder at very high level. One original message is there. There is an encoder which encodes that message, and it gives decoder to decode that message. When this process happens multiple times, multiple times, multiple times, then the learning happens. And then this architecture is capable of encoding and decoding the messages. Okay, let's go one level down from this. This is, just to make you understand what happens here. Let's go one level down from here and try to understand how it works under the hood. So if I take my example of, good morning, right? So let's say in English you say good morning. Okay, suppose the task in hand is to convert this message to its German form. Okay, German form. So in German, this is GUTEN, guten, if I'm pronouncing it right, and then MORGEN. Okay, so this is your English sentence and this is your German sentence. Now let's try to understand how encoder decoder will learn how to convert English to German. Okay, how to convert English to German. Okay, so first of all, what will happen is, if I have to draw my architecture that I was explaining you with the help of agent example, right? So here I will write all in small case so that there are no confusions. Okay, good morning I will write, it will go to the encoder. Encoder. Encoder will, what encoder will do, it will create a context vector. Okay, and it will give the decoder to decode it. Decoder. Now if we are training a language translation model, then decoder should give me this output: GUTEN MORGEN. Okay, this is the complete flow which I am highlighting here in red color. Okay, so this is your encoder decoder for a language translation model. Now let's go one level deep from here. Encoder is basically a sequence of LSTM cells. Not one LSTM cells, it can be multiple LSTM cells and multiple LSTM layers. Now, when I'm saying LSTM, guys, try to understand. It can be GRU also, it can be RNN also. But LSTMs work better with encoder decoder architecture, hence people use LSTM. Okay, so if I have to draw the encoder part only, so what I'm going to do here, I'm going to draw first of all encoder. So let's say understand these things very carefully, guys. This is very important for you to understand. Okay, I will draw a LSTM cell here. Okay, so I will write here my LSTM, and I will take one more, cell. You can, these things I have explained in the previous lecture, so you will be able to understand. Now, what do you feed to the network for the first time? For the first time, you will feed to the network the word good, right? Good is your first word in good morning, right? And at next time step, what you will feed to the network? You will feed to the network morning, right? You will feed to the network morning. Now, how LSTM and RN and these kind of models will work? It will just work in a recurrent fashion where it will pass like this, right? To the next time step, it will pass what it has stored, right? And then it will pass to the next. Okay, so this is how it will be. Now, if you remember, it is also outputting something at this step. Okay, but when we talk of encoder decoder, we discard these things. We do not consider these things. Okay, what we consider is only the final state output of encoder. Try to understand this carefully, guys. I am drawing encoder in front of you. What you will give to the decoder is only HT and CT. Now, this is where I was saying if you have some problem in understanding basic LSTM and RNN, you will face problem. If you have confusions on what is HT and what is CT, I have explained very much detail in LSTM video. Please watch that. Okay. So final hidden state and final cell state, to keep it very, very simple. Okay. Now, this this is what I have highlighted in red here is your encoder. Now what will happen? This will go into the decoder, right? Final state, remember, not the middle hidden state and not the middle cell state, just the final state, and middle things we ignore as I made here cross, right? Now let's take this forward and feed into the decoder. So from here decoder will start. Okay, and decoder is also a sequence of LSTM. Okay, LSTM. Remember, there can be multiple cells, there can be multiple layers of LSTM. And one more. Okay, and here we do not ignore the output from each time step. In decoder, we do not ignore the output from each time step. So when we are training the model, now understand this carefully, guys. When we are training the model, then what is the first word that you want to give to the decoder? What is the first word that you want to the decoder? You want to give to the decoder. So the first word that normally is given to the decoder is start. So from start, don't think that it is word start. No, it's not word start. It's start of the sentence, and it is to ensure that we put a word here which is not there in the vocab. In the second time step, we will give the first word here. Okay, so GUTEN. And in the third time step, we will give the third word. Remember, we are training the network here. Okay, so we know the output. We know the output here. Okay, so more gain. Now at all these steps you will have some outputs, and the final output that you will get becomes your output that has been predicted basically. But at all these steps, right, something is getting predicted, right? This output means something is getting predicted, right? This output means, so what should get predicted from my start? From my start, my first word should get predicted, right? So what is my first word that should get predicted? I'm not saying that is predicted. That should get predicted is the first word, right? GUTEN. From the second, what is that should be predicted? That should be predicted MORGEN. Okay, and third word will be end of sentence only. So normally starting and third word we normally ignore. Okay, so this is not that important. What are important is first what is getting predicted, then what is getting predicted. Okay, and here first you are giving start of the sentence, here you are giving end of the sentence. Now you have to understand one thing carefully here, how it will make the prediction GUTEN when we are giving a meaningless word here. We are giving a meaningless word here, right? Kind of meaningless word for this network. Then how it will make the prediction like this? Okay. So what will help is this HT and CT. Okay, HT and CT in terms of context vector basically, because what will come from here is not plain HT and CT, the context vector basically. From the context vector and start, it will predict the first word and it will go from here. So this is first level of depth that I explained you just now. Words will go one by one. Only final state of the output will go to the decoder. From the final state of the output, again words will go one by one in the time step, and then output will be predicted. Okay. From here, if we move little more advanced, then you let me explain you little mathematics of this. So this is your input, right? Input. So in your input, your words are good and morning. So in good, can I do a vector representation of good as 1 0, and can I do a vector representation of morning as 0 1? Okay. And in output, GUTEN, right? Guten. Can I do a vector representation? Again, the vocab changes. So I can write here 1 0, and here Morgan or Morgen. I can write here, let's say 0 1. Okay. And it will have one more words for start of the sentence basically. So let me change this embedding actually. So start of the sentence, one more word. Output, let's say, what do you want to give in the beginning, right? Start 1 0 0. Let's say that is the first word. Okay. And then Gunten is the second word. Okay. 0 1 0. And then Morgen is the third word. Morgen is the third word. 0 0 1. Now let's redraw our architecture one more time to understand this in a little different way. So let me take this LSTM cell, this LSTM cell. What is the first word that you are giving to the network, guys? The first word you are giving to the network is 1 0. What is the second word you are giving to the network? You are giving 0 1. These two things you gave. Now what goes out from here, we don't care. As I told you, we don't care about this. We just care about what comes out as the final hidden from here. Okay. Once it comes out, then it will go here. And what is the first word you want to feed here? You want to feed here 1 0 0, because that is your start. What is the second word you want to feed here? You want to feed here 0 1 0, because that is your second word. What is the third word you want to feed here? You want to feed here 0 0 1. Okay, different time steps I'm talking about. Now at all these steps, what will be the output? Think for a moment and tell me what will be the output here. So this is basically a probability distribution that we are trying to estimate here. Now there are three words here. Try to understand, pay attention, guys. There are three words here. For example, start, Gunten, Morgan. There are three words in the vocab. So at every step, right, what will get outputted is three probabilities, because it will pass through the softmax. Okay. So P1, P2 and P3. Understand this, guys? P1, P2, P3, three probabilities for start word, Gunten word and Morgan word. This is the predicted probabilities. What I want as the output, remember what I wrote in the red is predicted, but what is actual here? The actual first word is Gunten, right? So 0 1 0. Now try to see this difference here, guys. P1, P2, P3 is the probabilities of first word being start, Gunten and Morgan. But actually, 100% probability is it is Gunten, and 0% probability is rest two words. Now on one hand you have the probabilities, on other hand you have the actual probabilities. Now this becomes a optimization problem or loss minimization problem or cost minimization problem. Okay. And this is how the training will happen. I will take a pause and quickly tell you what is happening here. You are sending all the words one by one. From the encoder, you are taking the HTCT, the final state HTCT. You are combining this HTCT with the first start word, and then you are getting the probabilities of word falling in, for all these, basically a probability distribution function. And then you have the original probabilities. So now this becomes a loss optimization problem, right? And then when you train the network, your network knows, okay, this, how to optimize the network, right? So that is about how the training will happen here. Now there is one more concept here known as, uh, just give me a moment, I do not want to miss write something. So there is one more concept known as teacher forcing. Okay, so this is an interview question, and sometimes people may ask you, teacher forcing. Okay, teacherforcing. What is teacher forcing is, as I told you here, P1, P2, P3 are the probabilities of word being start word or Gunten or Morgan. Suppose Morgan is having the highest probability here. So basically the prediction is Morgan here, right? But actually it's Gunten. Suppose P3 is highest, so probability of Morgan is highest. So probabilities, the word is Morgan. So do you want to feed this knowledge? Do you want to feed these probabilities here? So let me draw this line here. See this dotted line carefully, guys. Do you want to feed these probabilities in the next step, or you don't want to do that? Okay. Do you want to feed these probabilities, predicted probabilities, in the next step, or you don't want to do that? Research have shown that if you feed the predicted probabilities here while training, then it takes more time to converge, and this is not useful for the learning as compared to if we take these actual words and give as input. Okay, if we take these actual words and give as input, as I was telling you here, actual words are given as input. Okay, and when you give actual words in training, then your training converges faster. Okay, but in prediction scenarios, in test scenarios, you don't have the actual words at all, right? You don't have the actual words at all. So what you will do, you have no option, you have to pass these P1, P2, P3 and the prediction from here as an input. So this dotted line will work there. Okay, this dotted line will be applicable in test and prediction but not in training, because in training you anyway know what the next word is. Okay, and when you are feeding that next known word, that concept is known as teacher forcing. Okay, so if somebody asks you teacher forcing means, in training encoder decoder, we know what is the next word, so we ignore the prediction and we take the next word and force it in the learning process. That is teacher forcing. So these things we have understood. Now let's go ahead and try to build a complete architecture by using our example. Okay, so what will happen? So I have words like good. Okay, this diagram, my purpose is to keep everything fresh in your mind through this diagram. Okay, I have the words good and I have the words morning. As you know, we will not use a simple one hot vectors and these things. We will use some good embedding layer, sophisticated embedding layer, before passing it to the LSTM network. So let's call this embedding layer. Okay, and when you build your own model, then also you will feel other embedding layers are working better. So this will pass through a embedding layer. Once it passes through an embedding layer, it will go to the LSTM cell, different time steps, right? It will go here, and like the same way, start from here, it will move ahead, it will take HT and CT. Okay, this entire thing which I'm highlighting here becomes your encoder. This entire thing becomes your encoder. Okay, and now let me draw decoder here. So for decoder, what are the words? For example, I will write here start. because start is where from we are starting. Then I will write here Guntain, and I will write here Morgan. I'm sorry if I'm mispronouncing it. I just took the word from the Google and trying to pronounce it. So apologies if I'm mispronouncing it. It will again go to embedding layer, right? Because this is how you are feeding the network. Embedding. Sometimes interviewer may ask you to do these things. Okay, so good to know. Okay, and one additional thing I want to draw here is, here you will have a softmax layer. Okay, so what layer you will have? Softmax layer. Why? Because you want to have a probability density distribution, whatever you call it, mass function, probability distribution function basically. Okay, so in your first time step, what is happening? Second time step, what is happening? And here, if you are training the model, then you will have three probabilities here, three probabilities here, three probabilities here, and three probabilities here. Okay, so P1, P2, P3, these are predicted. And if you are training the model, you will have actuals here. Okay, for example 0, 1, 0. Now same way for this, same way for this. Okay, and let me draw a red this thing for decoder also. This becomes your complete decoder. Okay, and let's take this line because this is what goes here as input, HT and CT. Okay, so all in all, what is encoder decoder? This is basically a process of taking a message, encoding it into the context vector, and making decoder learn to do something, either language translation or understand what was written or whatever it is, right? So this is how it will work all in all. And now what I'm going to do is I'm going to show you some of the Python resources which you can refer if you want to do a assignment on this. Okay, so as you know, these are complex concepts to understand. I will show you two different links. One is, first of all, thumbs up and courtesy and shout out to Mr. Gaurav Singhal. And here NMT encoder decoder with Keras. If you see this, right, I have run this personally. It works very well, and you can take this. What I want to do is I don't want to run the code through you. Okay, I saw many people are doing that, running code block by block. I don't want to do that. Rather, I want you to take this code and do it yourself. Then you will understand what you are doing in all these steps. Okay, write your encoder, write your decoder, and see what is working how. Okay, so I have done this in my Google Colab. It works well. Second, I want to show you uh, Keras link for 10-minute introduction to sequence learning. This is also very good link. Okay, the updated version is here. This one also you can try. All the codes are here. You can take some data and you can try. Okay, so that completes. I'll give both these links in the description. And again, courtesy to Gaurav for writing this beautiful, amazing article. So all in all, we understood what is encoder decoder, what are the architecture. We drew into flow, and then I'm leaving you with some Python assignments. Please give me a thumbs up, guys, if you're liking the content from generative AI and advanced NLP playlist. And let me know how did you do the experiment through the comments. I'll see you all in the next video, guys. Wherever you are, stay safe and take care.